Hi, we are Team Road to Prize Pool, represented by Tan Yijie, Ashley Chan Li and Lu Tan Yuxian. So our project is Crisis Link, a GeoAI decision support platform designed to help telecommunication operators maintain and restore connectivity during disaster. When floods and other disasters occur, connectivity becomes essential. People need it to request help, receive emergency information, contact their families, and access critical services. Crisis Link help operators understand where connectivity is most at risk and decide where recovery resources should be deployed first. Crisis Link activates after a disaster has been reported and verified. It is important to clarify that Crisis Link does not attempt to predict whether a disaster will occur. Instead, it answers a more immediate operational question. How severely will the affected area be impacted? Which community and infrastructure are exposed? And what is the minimum intervention need to maintain or restore connectivity? Our primary users are telecom, network operation and resilience team. The main beneficiary are affected communities, emergency responders, hospital, clinic, evacuation centers, and other critical facilities. Crisis Link support human decision making. It does not autonomously control disaster response operations. Our objective is to make network recovery faster, more targeted, and easier to explain. Crisis Link identify the most severely affected geographic zones and map the population, critical facilities, and telecom sites exposed in each area. It then compare the disaster scenario with normal network performance baseline to estimate potential connectivity degradation. Based on both network impact and human need, Crisis Link prioritize where the operator should act first. It recommends the minimum suitable intervention, simulates the expected recovery, and present the recommendation for authorized human approval. Our primary success metric is the percentage of the affected population whose connectivity is estimated to be restored. During disaster, telecom tower may become degraded, overloaded, inaccessible, or unavailable. Terrestrial backhaul may also fail precisely when demand for connectivity is highest. Telecom operator already have networking monitoring system, but conventional alarms may mainly tell them whether infrastructure is online or offline. They do not always provide the widest spatial context, how severe the surrounding disaster is, how many people demand on the affected infrastructure, whether hospital or evacuation center are exposed, or whether alternative coverage is available nearby. At the same time, emergency recovery resources are limited. Operator cannot deploy portable cells or technical teams everywhere at once. The real challenge is therefore not simply identifying a network problem, it is deciding where to act first and explaining why that location should receive priority. So, here is our solution methodology. Crisis Link address this challenge through three transparent intelligence layers. Firstly, is the physical impact severity layer. It uses geographic factors such as rainfall, hydrological condition, elevation slope, and proximity to rivers to estimate flood severity for each spatial zone. Then we overlay population, critical facilities, road and telecom infrastructure to identify what is exposed. Second layer calculates connectivity impact. It considers the area's normal network baseline, exposed telecom sites, nearby alternative cells, network redundancy, and simulated outage condition. The third layer calculates recovery priority. This combines connectivity degradation with human impact, including the affected population and the presence of hospital, clinic, evacuation center, or emergency services. Crisis Link then recommend the minimum suitable intervention. This could be monitoring, traffic prioritization for degraded but usable service, or a portal emergency cell with satellite backhaul when coverage is severely disrupted. So let me walk you through. Sorry, let me just jump to this. Benefit and expected impact. All right. So first, crisis link enable a faster response by bringing disaster severity, infrastructure exposure, network impact, and recovery recommendation in one command center view. Secondly, it improves resource allocation. Instead of immediately recommending the largest or most expensive intervention, crisis link identify the minimum action suitable for the predicted condition. Third, it focus network recovery on human impact. It helps restore access to emergency information and give additional priority to areas containing hospital, evacuation center, or other critical services. Finally, crisis link also improve the trust and governance. Its scoring layer remains separate and explainable. Simulated values are cleanly labeled, and every intervention requires human approval and creates audit record. So our current prototype has also a clear limitation. So for example, first, site outage, post outage, network performance, portable cell coverage, and recovery effects are simulated. So we do not currently proprietary operator data. We don't use that data on real-time capacity, cell load, or backhaul availability. The accuracy of the physical severity analysis also depend on the quality and coverage of the external rainfall, hydrology, terrain, and infrastructure data. Our intervention rule would therefore need to be validated with telecom operator before the real-world deployment. For the hackathon, we deliberately focus on one deterministic flood scenario to demonstrate a complete reliable workflow. We manage these limitations through strong guardrails, verified incidents, visible simulation labels, careful distinction between exposure and confirmed failure, and also human approval and no tracking of individual moments. So crisis link is designed with a modular architecture, allowing it to grow without changing its core logic. So it can expand to additional disaster type, geographic region, multiple concurrent incident, and cross-operator coordination. The simulated network provider can later be replaced with live operator integration, real network alarms, programmable network APIs, and satellite provider services. This platform can sustainably reuse open geospatial dataset when improving its model over time through the validated operator history. Ultimately, this project connects the disaster intelligence with telecom recovery decision. By helping operator restore connectivity where it creates greater human value, crisis link can reduce prolonged communication outages, strengthen critical service resilience, and also help communities stay connected when connectivity matters the most. So this is all about crisis link. We are Road to Prize Pool team, and that's all. Thank you for listening.